you guys see that? I mean, I understand why you said that, Melissa, but it's a...
Yeah, so it's not the first time that you see the point.
So why is it -2 to 2 here? Not because the point is there, because the first input I see that has an output is this one.
Okay.
And then every input in the middle has an output. Every input has an output.
Right.
So what's the first output I see?
-3.
-3, that's the first output I see. And then everything has an output in between, and then the last output I see is 3. So that would be -3 to 3. So it would look like this here. Well, they don't write it. Why do they write it that way? We know how to write it better. That's crap. Write it interval notation much better. So all this saying is x goes from -2 to 2. So I'd much rather write it like this.
Thank you.
This is my book, so I can write all over it. And then this is, the range would be -3 to 3.
Do we need to write this one like this, or just mention -3, 3?
I'd much rather you write it like this, to be honest, because interval notation is going to become more important later. Yes?
So when you use parentheses
Bless you.
continues, you use a bracket, it stops.
Let me make my own problem up here real quick.
Greater than or equal to it, you need a bracket.
Exactly. Equal to is inclusive. I don't have any. Alright, sure.
I definitely use it.
So real quick. Holy crap, that's really zoomed in. Alright, so if I had a problem like this is the problem they should have given us somewhere. And it was like this. Okay. What would the domain be?
-2.5, 3, -2.5, 3. Oh,
Don't overthink it. The first place I see it is almost -3. So how do I say almost -3? Almost -3. Right, so the parenthesis just means you can't include -3. Don't say -2.5. I understand why you would say that, but then you're leaving out -2.6.
Oh, I was actually reading the X line. I didn't actually go down to the numbers, so.
Well, I'm with you. Yeah, for domain, I'm only worried about where it is on the x-axis. So this starts at -3 almost. So if I can't include that specific one, I just put a parenthesis on it. And it goes up to what?
3.
3. And what do I put on that?
Bracket.
Because I'm allowed to include it. It's a closed circle there, right?
Yeah.
And then the range would be what?
-1, almost -1.
Yeah, almost -1
And
up to
3.
3.
That's the old
Bracket.
bracket.
Bracket because it's a closed circle. Right, it's a shaded in circle. So they didn't give you any like that, which is kind of evil. I probably won't, but I just want to show you. I mean, that's the real whole picture is you just put a parenthesis instead of a bracket if it's an open circle. You're not allowed to include that specific point. Yes. But what's the first output that I see? Do I see an output of -2 anywhere? No. Do I see an output of -1 somewhere? Yes. So as you're moving on the y-axis, what's the first output that I see? So I'm walking up the y-axis and I'm looking left, I'm looking over and over, and the first thing this little dude sees, oh shit, there's something over there. Okay. So at -1, that's the first thing he sees, and then he's walking. The last output he sees, of course, is at 3. I like it, maybe. So the lowest output to the highest output, that's range. Lowest input to the highest input, that's domain. What's up? Alright, he's looking really angry at me. Like, why is 4 not in the domain? Because it has no output. So when I say the lowest input, I mean the lowest input, it actually has an output. The function actually uses a line. I'm sorry. One whole semester I had this girl sit in the front row just looking at me. And at the end of the semester she said, I really liked your class. Oh my god, I thought you hated me. Alright. So, taking a step back. Let's look at one that's a little different. Let me cover the answer here.
These.
Woo! Focus. Focus. Okay. Oh! So what's different about this one?
It's not connected.
It's not connected. Now we talked about this specifically. Interval notation means it's connected because interval notation picks up everything in between. So can I use interval notation here?
No.
No. So what is in the domain? What's in the domain?
6.
Like what's the
I mean-
first input that has an output? -6. What else has an output?
-4.
What about 0?
No.
No. So far I got -6, comma, -4, comma, -2, comma, 2, 4, 6. So that's the domain. It's just those. Here it is. Roll. I'm stuck. Okay. There. That's the domain. Just listing all the x values that have. Because why would I want to use interval notation for this one next to it? Because how many x's work? An infinite freaking number. I'm not going to list those. I'm just going to say where they are. They're between this and this. So what would the range be? What's the first output that I see?
-4,
-4,
-2,
-2, 2, 4, 6. Don't say 2 twice. Right? I like it. Because that's an output. So then that's the out. There's the range. -4, -2, 2, 4, 6. Those are the outputs. Those are the inputs. I list them because they're not connected. If I wrote interval notation for this, I'm saying that these are connected, and they're not. I like it. This is the one, the set notation. Can you guys see this? The squiggly?
Oh.
The squiggly. Okay, I like it. I don't know if that's the kind you meant, Nathan. Let me see. What else could there be? We have these guys up here. Like, what's the domain of number 52? What's the domain? What are you thinking? What's domain mean?
X.
All the x's that you are allowed to use. So the right way to think about domain is there anything, any reason I would not be allowed to use something? Is there any number I can't square?
Yeah. Oh.
What's -3 squared? 9. Do you see what I'm saying? There's nothing about this function that has a problem. Let me relate that to this function. Does this guy have a problem somewhere? Yeah, what can I not take the square root of?
Negative.
Negative. So what's the only thing I can take the square root of?
0 and positive.
Yeah, so the domain here would be all the x's that are bigger than or equal to 0. Yes. Why did this guy's domain have to be written like this? Because square roots have a restriction on them. What about, what's wrong with, oh, this is just sketch a graph. They're not asking about domain, but what if I had this function here? What's the domain of that?
Not 1. All real number except 1.
Yeah, why? Because this guy has a restriction. You can't have 0 on the bottom. It has a bottom, so the bottom can't be 0. This has a square root. The inside has to be at least 0. Right? There's a restriction. This guy,
Could be all real numbers.
totally, number 52 is all real numbers. Because there is nothing that I cannot square. I can square everything. Yeah. Okay.
And why do we need to square?
It's just because that's what the function wants to do, right? See that? X squared. And then I can cut everything in half, and I can take 1 away from everything. I like it. Okay. I think that pretty much covers, I mean, these kinds are,
Okay, because of the x's.
I mean, look at this. This is kind of silly. These are silly to ask about domain and range because that's the domain and that's the range. I mean, they already gave you the answer, so I'm not going to give you one of those. Too bad.
Oh, come on.
Is this a function?
Yes.
Yes.
Why is it?
Because all of them.
Does 1 go to more than one thing?
No.
2 no, 3 no, 4 no. 3 and 4 go to the same thing, who cares? You guys see what I'm saying?
Yeah.
It's like asking some little kid, what's your father's name? They could have the same father, or the father could have the same name. So physically it makes sense, right? I like it.
Question.
And I know sometimes you might have 2 fathers, but I'm talking about the father that actually contributed part of his DNA to create you. That's what I'm talking about, yes.
Question 51 again. 51. Yes.
All right, now that's a little beyond. They weren't even asking for domain here, so I'm not going to talk about it, to be honest. I'm going to leave that one for next semester. They didn't ask you for domain on this problem. They just said graph it. But think about it. Let me think. Can you guys think about, so what's got to be true about the inside here? What's the smallest number that a square root can handle? 0. So what makes the inside 0?
1.
Negative 1. So it has to be, you have to use numbers that are bigger than or equal to negative 1. So watch this, watch this. Say it in English for me. What's going to happen? The inside has to be at least 0. And then solve it. Do you remember what I said? You always say in English what the restriction is, and then write it in Mathish. Here, the bottom can't be 0. Solve it. X not equal to 1. Bam. Here, the inside must be at least 0. Solve it. Bam. Done. That's how domain almost always works. Say it in English, and then write it, what you just said, and solve it. Yes, sir?
Aren't equal to negative 1 and equal to 0 different?
So, x plus 1 greater than equal to 0, right? Right, because the inside bigger than equal to 0.
Okay, so you just got rid of
And then subtract 1.
Is greater than, okay, sorry.
Yeah, what do you add 1 to make it equal 0? Negative 1. So yeah, we're solving an inequality in this case. Cool. I like it. All right, that went a little beyond what you have to worry about, but that's cool. Nothing wrong with that. I do that often. All right, anything else from chapter 8?
I think this question like this 51.
Oh yeah, exactly. You just have to graph it. But you have to know. So that problem we just did. The one with the square root of x plus 1. The actual question was, graph it. Chandel, can you turn one? Oh, God, this is So, I mean, if I ask you to make a table of values and graph this, what numbers would you use if I wanted you to graph this? Give me an idea. Definitely 0 is always a good place to start.
Negative 1.
Mixtures of negatives and positives, and definitely 0. If you don't know what something looks like, I always use these 5 to start with. That's my base 5 that I always do. If I'm not sure what it looks like, of course I know what this looks like, but I'm just saying, if you hit a function, I don't know what it looks like. Let me try these. Now, what's wrong with doing that with this? I have to kind of understand what I'm allowed to use, and that's one of the first things we use domain for is I know how to make my table if I know what x's I'm allowed to use, right? So what's the smallest x I'm allowed to use? We just figured it out.
0.
Negative 1 because that makes the inside 0.
Yeah.
I like it. So when you plug a negative 1 in, you get
0.
square root of 0 is 0. Let me see if you guys get this. I can plug 0 in because 0 plus 1 is
1.
square root of 1 is
1.
I don't want to use 1, because what's the square root of 2? 1.414. What's the square root of 3? 1 point something. 1.7. The next good number to use would be 3.
Oh, yeah.
Why 3? Because what's 3 plus 1? 4. Square root of 4 is 2.
That's why.
Alright, so domain helps you get the table started, and then you can be smart about using numbers that actually have the answers come out nice. Yes?
Are we supposed to know how to do square root yet?
No, not really. Every now and again, this book keeps throwing some roots in it. Chapter 10 is going to be roots. I don't know why this book wants to throw roots at us early, but they do.
Okay.
Yeah. But I think this is one of your homework questions.
So people are simple.
Yeah. But this is the thing to consider. You're just really throwing numbers in, but don't go too far down. But if you didn't use negative 1, then your graph would be incomplete. You wouldn't take it as far as it can go. So you got to know what's the lowest number I can use. Okay. All right. So here's what I want to do. I just want to do a little bit out of 10. Giselle, you all right? I'll leave you alone. I'll stop looking in that direction. Something's going on. I won't take it personal.
She's having a case of the Monday one or Tuesday.
I got you. Reminds me of the movie Office Space. Could you ever say something? No, man. No, I've never seen it. If you have never seen Office Space, go see it. The main thing they talk about in Office Space is the year 2000 computer problem. So that's a historical document now. All right. So finally, we're going to catch up to the book. We're going to start talking about radicals, and not from a political standpoint. This is what we call a root. It's a root. So, how do you say this? Square root of x. I love it. And see that of we use? How do I say this symbol? F of x. So square root is a specific example of a type of function, of a type of f. So that's the square root of x. The same way this is f of x. Because I'm plugging an x into f. I'm plugging an x into the square root. All right, cool. Now, we haven't talked about square roots directly until today, but we all know, we should know, for example, what the square root of 49 is.
7.
So let me contrast that to this. Let me make sure you really understand what this symbol is all about. Why is the square root of 49 7?
7 by 7, 49.
Because 7 times 7, 7 squared is 49. I love it. So the square root is sort of the opposite of a square, in a way, right? But if I write this, it's going to be a different kind of answer here. These are not the same thing exactly. Let me see if you guys see why.
49 is depending on x being 7, or dependent on x being only 7.
So the point is, remember this. What's the thing I told you about algebra with powers in equations? How many answers should there be?
2.
2. And of course, one way to get that is to bring the 49 over, and then what can I do with this? Break it down. What do you get?
X plus 7, x minus 7.
So you get x equals
7.
7.
Or minus 7.
All right, now, so please, dear God, if you're not sure where I'm going with this, just hang on. I got to really explain to you something that sometimes doesn't get explained to you. This symbol is the positive root. Why? Because there's a positive sign I know is there, right? So there are 2 square roots of 49. There are 7 and negative 7. Because there are 2 numbers that multiply by themselves to become 49. But when you see this symbol, like this, it wants the positive answer. So how would I get the negative answer? Like that. That means the negative root of 49. And that, of course, is negative 7. So that's how you get both roots of 49. This one's, the symbol specifically means the positive root of blank, whatever's in there. I really want to make that understood, because people get stuck in the idea that the answer to this is only 7 because the square root of 49 is 7. But no, there's 2 answers to this. There are 2 roots, square roots of 49. All right, maybe. Now, please, dear God, don't start telling me the square root of 81 equals plus or minus 9, right? What is the square root of 81? 9. Cool. But what's the answer to this?
X plus 9, x minus 9.
I like it. Cool. Maybe. All right. What about this here? What's the square root of? What you got, Jeff? I don't know, Jeff. 625.
Why, Jeff?
Because I'm evil. I was born a little evil, and then they taught me more evilness in math. So, I mean, what do you think you do here? What's the whole purpose? Why is the square root of 49 7? Because when you break 49 down, you see 2 7s. So the answer is 7. Really make sure you understand. So what do I do with a number I'm not sure what the answer is? I start to break it down. What goes into 625?
25.
Yeah. But would you does anybody kind of see that 25 goes in there? Maybe.
Yeah.
The first thing I see that goes in there for sure, in general, I think most of us would do 5, right? But you're right, 25 goes in. Well, let me start with what we would normally kind of pick up on. We normally think 5 goes in.
Yeah.
So 5 goes into it how many times?
A lot.
Okay, let's see.
130.
18 trillion to the trillion. Power's a lot.
131, I think.
125.
125. I like it. That's right. Now do the same. Now keep going.
5,
25.
then 5, 5.
I like it. So what do I have 2 of? Well, I have 2 5s, 2 5. So I have, what do I have? What's 5 times 5?
25.
25. 5 times 5?
25.
So what's the square root of 625?
25.
25, because it takes 2 25s to make 625. Another way you could do it is, every time you see 2 of the same number, you put it out. Another 2 of the same number, you multiply it. Maybe. So if you get a problem where the number inside is kind of gross, don't immediately reach for your calculator, because more than likely will be a piece of this where it won't let you use a calculator. You start to break it down so you can see what it's made of. That's what square root's all about.
But the first step, we need to see the 25 first, 625. We need to look at 25 to
Well, you
figure
just have
out.
to realize what can possibly go into 625, and we all should know 5 goes into something ending in 5.
Okay.
For sure. I like it. I like it. If it's even, you start dividing by 2.
Yes.
Divide by whatever you can see immediately. I like it. What about this here? What, Jeff? I don't know. No. Don't overthink it. Don't overthink it. What's on the top?
2 over 3.
Yes. Can't believe that shit. Square root of 4 is
2,
2. Square root of 9 is?
3.
And what's 2/3 times 2/3? 4 ninths. So you don't have to think about the whole fraction at once. That's what you guys were thinking. You're like, 4 ninths is 0.444. What the hell am I supposed to do that shit? No. Top and bottom. That's what we always do. What's on the bottom here?
1.
What's the square root of 1?
1.
1.
Right. It's just when it shows up, we're not sure what to do. We just attack it, though. Let's see, what other weirdness? Oh, here's a little bit of weirdness. You might think we did this one earlier, but we didn't. Here's where people make a mistake.
0.7.
0.7.
0.7.
0.07.
Wait.
So if you think it's 0.07, what do you get when you multiply that by itself? 1, 2, 3, 4. 1, 2, 3. Oh shit. So remember, when you have a decimal multiplied by itself, it's going to accumulate more and more decimal positions. Does that make sense? So square root of 0.49 is 0.7.
Yeah, 0.
Because I'm with you. I just want everybody to be with you.
Yeah.
7 to 7, 49. How many times you go back? Once,
One.
twice.
Yeah.
Bam.
Oh, wait, no, that's...
You let you take that in. That's a little fringe thing that's going to show up every now and again in the homework. But just so you know, when there's decimals, you got to slow down a second. Don't just go 0.07. That's not the right answer. It's going to be too small at the end. Notice something a little weird. I don't want to make too much out of this, but it's interesting. Square root of 81 is 9. How is 9 compared to 81? It is smaller. Square root of 0.49 is 0.7. How's 0.7 compared to 0.49? It is bigger. I like it, because when you square root numbers that are between 0 and 1, the answer actually comes bigger.
So I just did 49 over 100. And then I did,
Oh, I love it. Yeah, cool.
7 over 10.
That kicks ass.
And then I just figured it out. That's the same thing.
So you do 49 over 100, because that's what that is. And then like we just did up here,
Yeah,
7/10, which is 0.7. Kick ass. I didn't even think about it that way. I like stealing stuff from my students. There we go. All right, maybe. So, just a little bit more, and then we'll head out a little bit early. I immediately want to talk about cube roots, for example. Because if there's an opposite of squaring, there has to be an opposite of cubing, and so forth. So square root is kind of like the opposite of squaring in a way. So what would the cube root of 27 be?
3.
3. What was getting you ready for today was factoring sum and difference of cubes, right? Just breaking into 3 parts. So the idea of a cube root is it's looking for what is the thing inside made of 3 times, right? So 3 times 3 times. What takes 3 of it? You can say English, Jeff. What does it take 3 of to multiply to be this? There it is. That's grammatically correct and everything. Oh boy, get way up there, my Roman numerals. What about the, what do you got, Jeff? 5th root of 32. Again, don't immediately freak out. Roots are always trying to break things into parts, right? This is trying to break it into how many parts? 5 parts. So you take 32 and you start to break it down. 2 times 2 times 8.
Then 2,
2 times 4.
2,
2 times 2. 1, 2, 3, 4, 5. Answer is 2. What does it take 5 of to multiply to become this? So if you get a problem you're not sure about, break this guy down. That's how you do it. That's what roots want to do. They want to break a problem down into its parts and say it takes 5 of these to make this. It's the opposite of doing, what does 5 2s make? 32. So this says, what put together 5 times makes 32? 2. They are opposite operations of each other. Cool. I think that's enough for today. That's good. We'll stop there. We got to bring in some variables here eventually, but not today. See ya. You're out there, right? I'm sorry? Yes.